In this video, we're going to learn about proportionality reasoning problems. Number 1 says the speed of a ball is doubled with a fixed mass. What impact does this have on the ball's kinetic energy? What's the formula for kinetic energy? Oh yeah, it's kinetic energy equals 1/2 mass speed squared. So I need to know what to plug in, but they haven't told me. I'll just call the mass m, the speed v, and the kinetic energy ke. Then they say the speed is doubled and the mass is fixed. It stays the same. So the new scenario, we take the original speed v and we double it. We take the original mass m and it stays the same. It's fixed. And we have to find out what the new kinetic energy is. Well, I'll just call that ke2. The first step is going to be to distribute the squared to both things in parentheses. And when I do that, I have a 1/2 times m times 2 squared times v squared. But wait a second. I can substitute in 1/2 times the original mass m times the original speed v squared. That all together makes the original ke. So I can remove those three things and substitute using just ke. And what remains? This 4. So the new answer is 4 ke. That's what happens to the kinetic energy. It gets multiplied by 4. Let's see another example. We're going to skip down to number 3. Ball A has a mass m and a speed v. Look down here. Ball A has 4 joules of kinetic energy. Okay, let me just deal with ball A right now. A's kinetic energy is equal to 1/2 times A's mass times A's speed squared. What did they tell us to call the mass of A? Oh yeah, m. And what are we calling the speed? Just v. That kinetic energy for ball A is 4 joules. What else do they tell us? Ball B has twice the mass as A and half the speed as A. Okay. So B has twice, it doesn't have the same mass m, it has 2 times that original mass m. And it doesn't have the same speed v, it has, what was it, half the speed, v over 2. Okay, and we have to calculate the value of B's kinetic energy. Find what this is. Well, just like before, we cannot start until we distribute the squared to everything in the parentheses. So when I do that distribution, I'm going to have 1/2 times 2 times m times speed v squared times 1 over 2 squared. So I'm breaking up the fraction. I'm saying v over 2. I'm writing that as v squared times 1 over 2 squared. Or I'm writing it like this also. V times 1/2. Then I'm distributing the squared this way. Okay, time to substitute. If I take 1/2 times the original mass times the original v squared, those three things together make the original ke, which is 4. So I can substitute in for those 4 things, and I get the 4 joules. But what is left in the equation? Well, I've got 2 here and 1/4 right there. So times 2 times 1/4. When I multiply these 3 things together, I get 2 joules. That is B's kinetic energy. As a final example, ball A has a mass m and is moving at a speed v. A's kinetic energy is just Ke. All right. So for A, we're going to call the kinetic energy value just Ke. We'll call A's mass good old m, and V stands for A's speed. B is moving at 3 times A's speed. All right. So B has not the same old speed V as A. Ball B, the second ball, has 3 times the speed. And it doesn't have the same mass m. It has half the mass. In terms of Ke, determine the kinetic energy of ball B. So I'm looking for ball B's kinetic energy. And it's not the same. I can't write Ke here. This would be wrong. Why? Because I'm suggesting that the two values are the same, and they're not. We have to find what ball B has as its kinetic energy. So just like before, we're going to have to distribute the squared. That's always our first step. And we have a 1/2 times an m times another 1/2 times 3 squared, which is 9, times v squared. Now I can substitute. I find 1/2 mv squared. And those three things, I've got the original m, I've got the original v, so the 1/2 mv squared makes the original Ke value. When I substitute, I have Ke times 1/2 times 9, or 9/2 Ke.